Hey, good evening. So, this stream I'm going to be further generalizing the code. This morning we added plotting to the code. I'm going to put this down here so I don't miss any chats. We have our code window here. So, um, what we want to do today is we're going to work up here. Let's actually go to the description. I just put it all in here. Um, where the hell? Where's the description? Okay, so want to further generalize the code, adding bounds to region definition. Oh, right, add optimizations techniques, add bounds to region definition, in generalize get results. So take bounds, all right, add bounds, generalize results, run analyses, repeat analyses. This is bottlenecked until we have different optimization techniques, then add different to generalize or to optimize line location. Okay. Um, this will make urgent because or high priority because it's the first thing I'm going to do. Or yeah, make it the first thing. Okay. So let's put that up there. Get this window back. Cancel. Put that there. Okay, so the first thing we're doing is add different optimization techniques. So let's go look up black box, derivative free, because we don't know what our function form is. So we want a derivative free optimization techniques. And we'll put them in a list real quick. I have a document that I'm working on. Oop, wrong folder. Um, projects, nope. Uh, where is that? I think it's in YouTube. Yep. Okay. All right. So 12/15/2023. Derivative free optimization techniques. Get rid of this one. Don't care about saving it. All right. Here we go. All right. So we have just Bayesian optimization. All right, cool. So differential evolution. What just happened? Oh, done. Database online. What the hell? Online? Database online nonlinear extremum seeker. Extremum seeker. Um, all right, we're not gonna get that. Now, genetic uh differential evolution we already have. Bayesian optimization. Let's go see if we could easily implement that in Python. Okay, so Bayesian optimization. Yeah, so we're going to globally optimize a black box function. So this is what we want to do. Sequential model-based optimization in Python. Bayes search. Oh, here we go. All right, Bayesian optimization with skopt. In skopt, functions f are assumed to take as input 1D vector x and take as input a 1D vector represented as an array-like and return a scalar. All right, functions take in a vector and return a scalar. Yeah, that's what we're passing in. That's what we already have with our optimizable function. So that should be good. Okay, that doesn't look so hard. Let's make sure we have skopt. Take this plot out. Pip install skopt. Hmm. From S. Why can't we install it? From skopt import. From skopt import gp underscore minimize. All right, so now we have to figure out how to install scikit optimize. Pip install scikit dash optimize. Okay. Nice. Exit. Okay, let's go over here. Plot region. So here, optimize line location. We're going to pass in optimization type. Should be string, and it defaults to differential evolution. Then we're gonna do define test valid optimization type. And then pass in optimization type, and we're gonna say up here valid optimization types is equal to, so the first one is differential evolution, and we also want to have, damn it, why does that do that? I don't know. Okay, I'll just put that there. And then Bayesian. And then here we could say if optimization type not invalid optimization types, raise exception, and we're going to say optimization type is not a valid optimization type, must be one of optimization types. Must be one of valid optimization types. And then we could say must be one of valid optimization types. And this we could do dot join. So we're going to join everything in valid optimization types with just a space. Join it with comma space. All right, now we could save that. Now we have a test for the optimization types, and then we could just say here test valid optimization type of optimization type. Okay, now down here, res, so now we could say if, oops. Hey. Dogs were barking. So here we say if optimization type is equal to differential evolution. Go ahead and do this, and then we could say elif optimization type is equal to Bayesian pass. We're going to write that real quick. So then let's go up to the top and say from skopt import gp underscore minimize. Then back down to optimize line location. Okay, so otherwise, if optimization type is Bayesian, we're going to say gp.minimize. Minimize function, so minimize optimizable func. The bounds we want to pass in are a bounds. The acquisition function. What is an acquisition function? Acquisition function. Okay, then well, that is confusing. So then we get a Gaussian process on it, I guess. First column shows the following: the true function, the approximation to the original function by the Gaussian process model, and how sure the Gaussian process is about the function. From skopt.plots, import plot convergence, and then we want to plot the convergence of res. So I'm a little bit confused with what to do with res. But we should be able to let it optimize, and all this stuff comes from reading the optimization file. So let's go test this and make sure it works. So let's do test optimization should be 1. Now in test optimization, Let's not do free circle anymore, but let's do triangle because that is our fastest to optimize. And let's make sure we're returning percent return. Get region, assess region. Okay, so we're returning percent return. So let's go run that. Expecting an end to the F string. Where's the issue? 288. Optimization type is not a valid optimization type, must be one of. What? Must be one of. Oh, it's because I used. Man, this is something I'm always doing. I gotta stop doing this. It's because I used double parentheses instead of single. All right, good. Let's get out of there, save it, run it again. Okay, nice. It's optimizing. I'm gonna run to the bathroom real quick. I'll be right back. Did it already finish? May have already finished. Should be single optimizations. Today, 3. When did this run? 241. Yeah, so this is the one that just ran. Whoa. So that optimizes way faster and only gets the wins in the region. Wow, that's a way faster optimizer. So what if we optimize, what if we say instead of differential evolution, oh, region type equals triangle, so this was using differential evolution. I think it was differential evolution. Okay, so back down to test optimization. And then we're going to say optimization type is equal to differential, no, not differential evolution. Evolution type is equal to Bayesian. All right, now let's see what the Bayesian optimization does. Okay. GP minimize. The aliases. So GP minimize isn't working because of a problem in NumPy. So let's get that. Okay, GP underscore. Okay, now Why is GP minimize not working? It's not clear which line of the code is raising the exception, but I suspect the culprit is an skop not having caught up with the full deprecation of np.int. You could downgrade numpy to 1.24, or this change you could do from degree to pass the integer dimension as a array of integer. In fact, it's a line opt fit that raises the error more precisely. I replace all np.int with int. I managed to resolve this by simply adding this line before calling fit. Oh, hell yeah. Okay. So before we call the optimization in, we can say, okay, so if the optimization type is equal to Bayesian, np.int is equal to int. Okay, now let's Python 3 analysis1.py. Nice. So that got our Bayesian optimization to work. This is index 5. And I wonder how long it will take. So we think we've done Bayesian optimization. Let's make sure it works. Coordinate descent and adaptive coordinate descent. So let's look that up, how to implement in Python. Coordinate descent in Python. Stack Overflow might be better for that. I'm not sure how to do coordinate descent. Okay, so gradient descent for iteration in each iteration. Okay, so there's not anything ready built for this, so I'm going to try to, or I'm going to skip that and look for other stuff. I just want stuff that's pre-built right now we can just plug in. If we end up wanting to look for more, then we can do that. So here's the Bayesian optimization result. Now, what we should do is test training years plot. Test training years plot. Okay. And then a dot to CSV. So we should say perform optimization. Okay. So now in perform optimizations, we need to pass an optimization type. Optimization type should be a string and it should default to differential evolution. And then when we call the optimizer, okay, optimize line location, then here we say Optimization type is equal to optimization type. And then down here, when we're testing training years, we can say perform optimizations, and then optimization type is equal to Bayesian. And region type instead of hybrid should be triangle. And then instead of hybrid here, it should be slash Bayesian. No, slash triangle. Okay, slash Bayesian triangle. For year in each year, if os.path.exists optimization data slash training years test optimization data slash training years test slash hybrid. Okay. So this just does if this doesn't exist, make it. Hybrid. I'm just wondering if that will work. I think it should work. Optimization data, training years, Bayesian triangle slash year. Let's test it. So test training years is equal to 1. And then take test optimization off. And then now it's going to do the training years test on the triangle method. No such file or directory. Training years test Bayesian triangle slash 1. Okay, this so let's just make a function. Training years test. Okay, and then the things we want to pass in, we want to pass in how many years you want to train on. Want to pass in the directory and number of years to train on the directory, the region type, and folder location. Folder location and optimization type. Okay. Now let's copy all that stuff in. Okay, then we've already got num years. If not os.path exists. So if the folder location doesn't exist, if the directory doesn't exist, make the directory. Make the directory. Now for year and number of years, if not os.path exists, let's say directory name. If not os.path exists, f of, and then this should be optimization data slash training years test slash, and then we get the directory name. And then say, if that doesn't exist, make it. Now for everything in num years, optimization data, if not os.path exists, so go to the directory name and then slash year. So if the directory name doesn't exist, make it, then go in there. If that year doesn't exist, then make it slash directory name slash year. Then perform optimizations. Folder location is optimization data slash training years test slash directory name slash year slash directory name slash year, and then a equals pd dot read csv. No, don't need that anymore. Oh, we do need that. So that reads whatever the most recent was. And then, oh, does this actually not matter? So training years test triangle 1. Okay, results.csv. Nice. So where does this happen? For year and test years, perform optimizations, folder name slash results.csv. Okay. So we don't actually need to worry about any of this anymore. Optimization type is Bayesian, but optimization type should just be equal to optimization type. Now we've got that. We've got perform optimizations. Okay, define training years test. Oh, folder location. We didn't need because we have the directory name. And then we could say down here, get training years plot of, and we want the label to be, the title of the plot to be the directory name. And then we want to say optimization data. Okay, so this is just optimization data slash training years test slash hybrid. So the slash directory name. Okay, get training years plot. Directory name. Yeah, I think that should work fine. So just to make sure we don't still need all this stuff yet, we're just going to comment that out for now. And then if it's true, we're going to say training years test of, so num years should be np.arange. Could actually just leave this in, say make it num years. Okay. Then otherwise we also have directory name should be Bayesian triangle. And then region type should be triangle. And then optimization type should be Bayesian. Region type for your num years. Perform optimization. So here we should say region type is equal to region type. Now everything's called up there. Okay, I think we should be good. Let's go try to run it. Make sure that that test is on. Test training years. Okay, so we're going to run that. Now let's go make sure that it's saving in the right place. Bayesian triangle. First we're testing one on one season back, and it's on 2008. Okay, so we're gonna let that run while we go implement the other stuff. So Bayesian optimization appears we have implemented correctly. Waiting to see results. Now coordinate descent and adaptive coordinate descent need to be implemented by hand in Python. Skipping for now. So differential evolution is already have it. It's the first optimization technique we used. Okay, now data-based online nonlinear extremum seeker. I don't think we're going to be using that, but you never know. All right, data-based online non-linear extremum seeker. A Python implementation of the done optimization algorithm. For, but not limited to, sensorless adaptive optics applications. Particularly efficient in minimizing unknown cost functions through the acquisition of a limited amount of measurements affected by noise. Okay, so done algorithm looks a bit complicated, so I'm skipping for now. Python implementation can be found here. All right, evolution strategies, natural evolution strategies. Okay, so let's look up CMA ES Python. Stochastic derivative-free method for numerical optimization of nonlinear or non-convex continuous optimization problems. Okay, so it looks like they have it. Python pip install CMA. All right, let's go try to get CMA on here then. How's the results doing so far? So positive 2008 and 2009, that doesn't mean much to us. Um, pip install CMA. Oh shit.